Okay, so this problem, what we're doing is we have a mixture of pentane and hexane, and here I've listed the vapor pressure of each substance, the volume of each substance that we have, and the density. Okay, so this mixture is going to produce a vapor pressure that's somewhere in between these two values. So what we need to do to find out what the vapor pressure in the container would be is we would have to use this equation where the total pressure is equal to the mole fraction of one substance times its vapor pressure plus the mole fraction of the other substance times its vapor pressure. So in order to find the mole fraction, first we have to go to moles. So we can use the volume of each substance and multiply it by the density, and that's going to get us the number of grams, and then from grams we can always go to moles. So what we would do is find the number of moles of pentane to be 0.22. We would find the number of moles of hexane to be 0.345. So finding the mole fraction is basically taking the moles of that substance and dividing it by the moles of everything in the solution. So for pentane, 0.22, when you add up the two together, you get 0.565, and that becomes the denominator. So your mole fraction of pentane is 0.39, and your mole fraction of the other substance would be 0.61. And you could just figure that out because there's only two things in there, so they should add up to 1 when you add up the mole fractions. Anyway, then you plug in the values. So your mole fraction, pentane times the vapor pressure, is 0.39 times 511, plus the mole fraction of your hexane times its vapor pressure, which is 150. When you add up those values, you get 291 torr. The reason that pentane would have a much higher vapor pressure than hexane is it's a smaller molecule. Both of these are very nonpolar, so there's very little intermolecular forces. But since this one's larger, it takes more kinetic energy for it to want to go into the vapor phase. So larger molecules, if considering polarity to be the same, are going to have a lower vapor pressure, and they're probably going to have a higher boiling point as well.